Good
Hey,
morning.
Salman.
Hi, Rich. How are you doing?
All good. You should be able to share already, so it's
Okay,
all yours.
so I'm going to start, and because since it will be uploaded and anybody can watch it later. Sounds good? Okay, so one important thing that so today what I'm going to do is let me share my screen first. So last time we talked about one thing. We looked at how exactly is, okay, I think I need to mute this because it is making a lot of noise. Okay, so I think this is good. Okay, so last time what we did is, let me quickly show you. And it's my bad that last time I was not able to upload the recordings and things like that. They are there, so I have kind of like changed them. And we are going to go through quickly what exactly we did last time. So last time we started with simple basic data cleaning steps, and we started with simple basic taking a look at the head of the data, tail of the data, and getting the feel of the data. That is what we did last time. And then what we did is we look at the shape, and then we look at the data types, and we look at the null value distribution, which we did over here. After that, what we did is we basically figured out how many null values, percentage of null values, and we see that these two columns are the ones which needs fixing. Obviously, these are other columns which needs fixing and things like that. And that is where I'm going to talk about. So today's session is mainly about how to handle missing values. There are so many different strategies. So I'm going to break it down for you step by step with proper names so that if you ever feel like searching it or researching it on your own, you can always do that. So because first of all, what exactly the name we give to that particular strategy. So we are going to talk about several different strategies. Obviously, I will not be able to talk about every single strategy out there, but we will talk about it. And then we also take a look at the null value columns. These were the null value columns. And we also visualized kind of like we looked at the missing values and things like that. These are the things we did. We looked at the descriptive statistics and those sorts of things. So I think this size is better. So everybody can see my screen and read from my screen properly, right?
Yep.
Okay, because this will be going on YouTube, and on YouTube I feel like my last video the size of the text was too small. So if you can read it, that's amazing. If not, let me know. I can just magnify it. So descriptive statistics, check for the duplicate entries and unique value. This is what we did last time. Now what I'm going to do is I will show you step by step how to handle missing values, and I will go in detail about theory first and what are the assumptions that we make, what are the advantages, what are the disadvantages of a particular techniques are, in which situations you should apply, how to tackle numerical variables or numerical columns, and how to tackle categorical columns, and in which situation what you should do. So I have kind of like, I will break it down in such a way over here. First of all, if we talk about handling missing values, so handling missing values, there are few things that can happen. Why exactly? The first question you should ask is why the values are missing. There are several different ways or things that can go wrong. The first thing can do is, or you can say that values are missing because they are missing completely at random. So they are missing completely at random. You will be seeing, or you must have seen some short forms like this, MCAR. that means a particular value is missing completely at random. When I say completely at random, that means the value which is missing, it's not like from the first top 25, from the last 25 in the or this particular month, the values are missing or something. The reason is basically when they are missing completely at random, that means when you fix those particular values, majority of the time, the distribution does not get affected depending on what percentage of data is missing. So that is one of the possible thing that can be reason why values are missing. They can be missing at random, completely at random. Then there is missing at random. That means they are not completely at random, but they are missing. And the final one is missing not randomly, not at random. These are the possible choices that we have when we look at the missing value. We need to determine which category our particular column in when it has missing values. You need to determine that. And based on that, different techniques that we use, some techniques are good for missing completely at random data. Some techniques are good at missing at random data, MAR. And some techniques are good at when it is not at random, so MNAR. These are the three possible assumptions you have to look at before you start getting into what kind of a technique you're going to use to handle missing values. Now, let's talk about few ways. Now, there are two ways I'm going to talk about. Okay, so when I say two ways, so technically, I would kind of like divide it into two sections. So I would say the one way is simply removing a particular data point or the row or whatever you want to call it. So removing the missing values, that would be one of the possible choice. The other choice is you can impute them. Now I'm going to talk about both of them. When we talk about removing them, the other name that we give it to is what we call is complete case analysis. So this is the name we give when we are removing the values. What does this complete case analysis, in short for CCA? You would be seeing this in statistics books or things like that. Okay. So what is complete case analysis? Complete case analysis means you have to remove the complete row wherever any of the column has missing values, which means if you have a column or let's insert a column. So let's insert a table somewhere. I think we have put in here. So let's say I have some value here, some value here, here. I have some value here, and I have some value here. If I have this value missing, which means I'm going to be removing this complete row. This particular process is what we call complete case analysis. And we are going to talk about in detail about complete case analysis, because there are some assumptions that we need to make when we are doing complete case analysis for it to work properly and give us better results. And let me tell you one important thing. So the one important thing is majority of the time, this is the last thing you have to do. Or this is not used as much, but it is used when the data is missing in a very small percentage. If you have large amount of data missing, then this is not the ideal scenario. If that happens, then we have to go to the imputation part. And when we talk about imputation part, then we have several different techniques. We are going to talk about two of them. So one is univariate, and one is multivariate. The name is basically telling you what exactly is happening. Univariate means you look at one single column, and that one single column, let's say if this particular value is missing over here, that means I will look at only this column and I will use information from only this column to figure out what should be the value here. I can either use mean, I can either use median, or I can either use, there are multiple techniques. So when we do only one column is responsible for imputing the missing value, we call it univariate. What if I have to use the information of the neighboring columns as well? That is where multivariate imputation comes into play. So univariate, when we talk about it, technically it is the simple imputer that we use is a univariate imputer. So the simple imputer that we use is a simple univariate imputer. And when we talk about simple imputer, now we need to look at whether my column is numerical or it is categorical. What kind of a variable you are dealing with. So if it is numerical, then we have to take a look at few things. For example, we can do either mean or median imputation. That means you will find the mean of this particular column and impute every missing value with the mean of it. Or you can find the median of this column and you will change or replace all the missing values with the median of the column. The other thing that you can do is you can induce random number. Instead of mean and median, you can introduce a random number. We will talk about all these techniques one by one, and we will see which would work best, because we have to check whether it is working really well or not, because it can change the distribution, and we don't want the distribution of the data to be changed when you are doing imputation. That is our goal, and we want the distribution to remain as same as possible. So sometimes values at random would be a one thing to do. And in some cases, you will find a bell curve. For example, you will find the distribution of this particular data. So for example, like if I show you the distribution will look like a bell curve like this, let's say. Then what I can do is I can impute with a value which is at the edge of the bell curve, either here or either here, because this way I'm kind of like replacing the value which is almost an outlier for my data. So that means I can highlight that this value is missing, which means I want to give importance. Yes, I'm not replacing the value, some number which is somewhere in the middle of it. I'm replacing it with values at the edges. When we do that, we will talk about that. So we call it end of distribution imputation. So these are a few things you need to keep in mind. What if it is a categorical variable? If it is a categorical variable, then you would be doing the most frequent one. We call it the mode. So mode is technically the most frequent. Mode means the most frequent. When you're dealing with categories, technically what is happening, the mode is basically the reason over here. So the second thing that you can do is you can replace it with a missing. For example, since you have categories, you can introduce a new category, which is a missing category. So which means all the values which are missing, you just replace it by category name missing. And sometimes it is important to just use that, because depending on whether it is missing at random, completely at random, or not at random, depending on that, just giving this information would tell you whether you need to do this or not, whether mode would work fine, or missing, or creating a new category called missing, or some whatever name you want to give it, you want to do that. Okay. Then, so these are a few techniques which come under the umbrella of simple imputer. When you go to sklearn and you use simple imputer from there, you would be able to do all this with simple imputer. Now, let's talk about multivariate. So when I'm going to talk about multivariate, so here there are so many different techniques, but we are going to talk about only two techniques. So I will talk about only two techniques. One is KNN imputer, and the other one is the iterative imputer. The iterative one is basically you are using some machine learning to get the value, but you are doing it repetitively in order to improve or get the value as accurate to the real value as possible. We are going to talk about that in detail in most will be our next session, because I don't think I will be able to cover much until that, because these things will take a lot of time. Because what we are going to do, we will do these imputation and we are going to plot their distributions and we are going to compare the distributions and we are going to go by column, and then we will see it at work on our data set. So when you were doing it, so when you were doing data pre-processing, or when you were doing EDA or something, because these two processes overlap. So one important thing is, it is not as you cannot do it as quickly. Yes, for the doing it roughly, or for the first naive model that you want to make or something, you want to do as less as possible and keep things simple and everything. But when you are going in detail, you have to look at every column. If we have, so we have very limited number of columns, but still we have a lot of columns. That means you would have to go column by column, because maybe one column would require a different imputation technique, the other column would require a different imputation technique. You don't need to apply the imputation all on that same data, exactly the same type of imputation, because what particular column is giving you information about, for example, whether the values in that particular column are one of these three categories. Based on that, you will determine whether which technique would work well. So you need to come up with different techniques. And that is where you must have heard about column transfer or transformer, not transfer. Column transformer method in sklearn. What does this column transformer does is, basically it lets you apply different imputation or whatever. Right now we are talking about imputation, so I'm giving you an imputation example. This column transfer method in sklearn, it provides you or lets you apply different imputation to every column. So what you can do is, you can create a list of different columns with what kind of imputation you want to do, and then you can apply this column transfer to the whole data. This saves a lot of time. I'm going to talk about that when we are done with this KNN iterative and all these basic ones, and I'm going to show you how to implement column transformer, because it's going to save your life. Because it's going to save you so much time, and that's why I'm calling it life. Because if you start doing manual imputation of every single column, it's going to take forever. So that's why this column transformer is a game changer, and I will show you how to implement it. So there's another thing which we call pipeline. That is, you can find in sklearn, which can also, so column transformer lets you apply different things on different columns of the same data set at once. The pipeline thing can create pipelines for you, which means if you want to do multiple steps, you want to do step number 1, then step number 2, then step number 3, and step number 4 for every single piece of when you're creating, for example, data pipeline, that means when you have deployed your model, then now you are, or a customer is using your model, which means when the customer will feed the data, that data would have some pre-processing needs to be done, which you have already done, which means you must have created a pipeline that whenever you feed the data to the model, it's going to go through several steps. First, I'm going to handle the missing values. Then I'm going to get rid of the unique value, means duplicate values. Then I will try to go and do some encoding technique. Then I will do maybe dimensionality reduction, feature engineering, or whatever. So this pipeline also saves you a lot of time. So there is one thing as pipeline, and there is one thing as make pipeline. There are a few differences in it. We will talk about it when we get to that, but I'm just introducing this because I see that some of you are already doing EDA and everything. So do check them out, because you can do multiple steps in one go with one piece of code using these 3 important methods in sklearn. So This KNN one and iterative one, I'm going to break down the background mathematics as well. I'm going to show you what happens in the background when KNN is doing its job, what exactly is happening. And you have seen that KNN takes a lot of compute power, right? So it takes a lot of compute power. Iterative one also takes a lot of compute power. And you would see why exactly it does that. And what are the advantages of all these? What are the disadvantages of all these? And what are the assumptions of all these? We are going to talk about it. So anybody has any questions so far? Everyone's good? Please feel free to ask me a question, raise your hand, and whenever I'm done explaining a particular topic, I can answer your question. So are there any questions in the chat?
I've just been responding to a few. It's just most people, it's like, how do you decide on which techniques to use between the univariate and multivariate ones?
I'm going to break it down. Don't worry about it. So I give you an overview that these are the techniques and these are the things to do. Now let's get into simple imputing. In fact, not simple imputing. Let's get into the basic one, the removing this complete case analysis. Let's start from that. Okay. So what we are going to do is let's start from complete case analysis. So maybe let me type it down. My writing is not that good. So complete case analysis. Let's talk about that. So first, what I'm going to talk about is the assumptions for that. So what are the assumptions that you need to keep in mind before you do the complete case analysis? Keep one thing in mind. Complete case analysis means removing missing values. This is another name for it. You can also call it CCA. Yes, as I will share these notes, but I would recommend you to watch it again on YouTube, because just the notes would not help you. Listening to the description or explanation along with that would be a better thing. So yes, I will share the notes if you want it. So let's talk about the assumptions. The first thing, the assumptions that we need to keep in head or keep in mind before applying this, that this strategy is only and only applied when the data is missing completely at random. That is the first assumption. If the data is not missing completely at random, then you cannot apply this strategy, because then it's going to change the distribution of the overall data when you kind of like remove the data this way. So when we say missing completely at random, that means it's not, sometimes you do not put the data, or missing values sometimes is one of the category. That means you are not missing when you are entering the data, or you are creating a data set or something. You left a particular column blank yourself for a particular reason. That means it is not random, it is intentional. So when it is intentional, you need to determine it whether it is intentional or not. How to do it? That's where means you can say you need to have knowledge of a particular field. Means that's where knowledge of a particular field come into play. That's where research comes into play. You go and search about that, what are the different ways to collect this particular data set. For example, last time what we did is we basically did the climate change thing, and there were some columns which were missing for majority of the days, about 60 or 70 or 80% times. Okay, so okay, just give me a second. Okay, so which means in that particular scenario, you cannot apply. Means when the values are missing intentionally, you cannot apply complete case, or removing missing values is not a good strategy. So what is random and what is non-random? That is what I'm telling you, that sometimes you leave the columns or values blank yourself intentionally. Intentionally means, for example, the recording instrument was not working that day. It is not intentional, but it is not completely it is due to a particular fault. It is not completely at random, or things like that. So sometimes I'm leaving a particular entry blank because I'm saving some time. For example, writing the name of a particular category, or leaving a column blank, or leaving a particular value blank saves time. For example, if I'm recording or if I'm collecting data. So let me insert a table here, any random one. So let's insert it here. So for example, I'm recording data and I have to record hundreds of columns of data. And if I'm reading some instrument, or let's say I'm reading from a particular sensor, the values of a certain thing, then if I see some value, or if I see a change in value, for example, then I'm going to record it. Otherwise, I will leave it blank, because recording it and writing the same thing which it has been already been doing, it saves time. So sometimes I will leave certain columns blank because my intention is to save time in this scenario. There are some scenarios. So keep one thing in mind: data collection is a very, very, very time consuming process. So so far, you're in your data science journey, if you have never collected data yourself, I can understand you don't know that. But when you collect data from manual sources, data is very, very, very dirty, and it takes a lot of time. And then people come up with different ideas to save time in collection of data. And that's where those strategies comes into play. And that's where domain knowledge comes into play. So which means if you have a domain knowledge of a particular thing, you will understand why the data is missing. So that's where data science is not about applying statistics and applying different calculus and linear algebra or things like that, or at data. Understanding the data is part of the job, and you can become better at it when you become expert in a particular domain. So that's why domain expertise is also a big part. Okay, so so I think this is clear now. What is completely at random means? Completely at random means it is not intentional. It is completely randomly some values are missing. Means it's not like you just deleted the first 50 values. You just deleted the last 50 values. If you want to create your own data set, for example, let's say next time you want to become a lead of an Omdena chapter and you want to create a data set, you want to challenge your participants in a way that they should explore all these techniques. Then what you would be doing is, one column, you would be deleting data specifically of a particular category intentionally. And then for one column, you would be deleting the data completely at random. Completely at random means at different values, at different levels. And third one is randomly, first 50, last 50, middle 50, or something like that. That is random. So handling those three columns would be different strategies. So we need to kind of like go and read about it and see the distribution, that whether what kind of a data is missing or things like that. And that's where the research comes into play, the domain knowledge comes into play. Now, I was talking about the assumption for complete case analysis. Let's talk about few advantages. So when I talk about advantages, one important thing that you need to keep in mind is it is very easy to implement, because dropping values is simply drop NA. So in pandas, you write the name of the data frame, dot drop NA, and you are done. You have just dropped all the null values in the data set. It's pretty straightforward, but it is easy to implement. So because there is no data manipulation steps are required here, you just need to understand the column and then you just implement it by just using drop NA, and that's it. The other advantage for this one is it preserves the distribution. So if it is missing completely at random, then it will preserve the distribution of data. So I'm going to show you today in our data set. I will plot the original data set, and then I will remove the values, and then I will plot the new data set on top of each other. And you're going to see if the distribution is getting disturbed or not. If it is getting disturbed, then this is not a good strategy. And we are going to do that for every column. Okay. So preserve the distribution of the data. So that these are advantages. And now, one important thing. Let's talk about few disadvantages. Obviously, in which situation I should not do it. This is the first one is pretty straightforward. If so many values are missing, I would not do it, because then I would be losing whatever the amount of missing values I have. I would be losing that amount of data, and I don't want that. So disadvantages. Let's talk about them. The first one is means so what happens? Wait a minute. Oh. Okay, so disadvantages is you can remove large chunk of data. Can remove large chunk of data. That is one of the disadvantage. The second disadvantage is if you remove all the missing values, then in production, your model will not be able to handle missing values. The model will not know what to do if the values are missing. For example, when your model is in production, that means a customer is using it and customer puts in a data in which some values are missing, then your model is gonna be throwing in errors. Why? Because your model does not know how to handle missing values, because you removed all the missing values and you did not add handling missing values steps in your data pipeline. That means your model is going to throw in errors. So in production, it will throw in error. So in production, model will not know how to handle missing values. So I would just write it down. In production, model will not know how to handle missing data. And that is a very, very, very important thing to keep in mind. So these are few disadvantages. Now, question is when to use it. Now let's summarize it. When to use CCA? The first thing is the percentage is not fixed. Means what percentage of data you should be missing in order to apply it. There is no hard and fast rule. Means I know that Awais and team applied 3% rule, I think. So 3% to 5% or 1% in some cases. So depending on what kind of a data set you are dealing with, how many values you have available, you determine that number on your own for every data set. And you check whether by removing 3%, does it change the distribution? By removing 5%, does it change the distribution? So you play with this number. This number is never fixed. So that's why I'm just writing few numbers and I'm going to not write. So means percentage is your choice. So percentage is your choice depending on data. depending on data you're dealing with. That is one thing. So, and the second thing is the values should be missing completely at random. These are the two things. When to use CCA, if the column has missing values which are completely at random, or if the missing percentage is very low, you are not losing a lot of data by doing that, then you should apply it. Okay, so keep one thing in mind. For example, if you have 95% missing data, in that scenario, you're gonna remove the row or not. Just give me. So I'm supervising my son as well, so just don't mind that. Okay, so when to use CCA, we talked about it. So these are the two things you need to keep in mind. What I was talking about is, let's say the data is missing a lot. For example, if 5% of data is missing, you're gonna remove the rows, the complete row. And if let's say 95% data is missing, what you're gonna do, you can remove the column as well sometimes. Means that column which has 95% missing values, maybe it is not a hard and fast rule. You have to have kind of like domain knowledge and see whether the values you are removing are not taking out some information that can influence your model. So be very,
Salman, we've got 10 seconds left. Just refresh this, okay?
Let's restart it. Yeah.
Yep, cool.
Okay. So I'm going to get started. So what I was saying is, if 95% of the values are missing, you can remove the column, but you need to check whether that removing of that column is gonna, are you losing some information that can influence your model? Then you need to be careful about it. Maybe only 5% values are very important. Maybe the accidents that were happening, which are kind of like very severe, maybe they are just 5% of those accidents. And if by removing them, you will be removing the information about those severe accidents. So you need to be very careful about that. Before removing anything, always ask questions that whether it is determining anything. So compare, look at the distribution of the data. Is it changing the distribution of data or not? Then you have to look at the correlation between other variables, covariance of between the other variables, and so many different things. So we're going to talk about that. Okay, now let's look this in practice. Let's look the coding part over here. So I'm going to move to here. So I will be uploading. So this is the continuation of the previous notebook. So we started with the steps. So I installed my missing no library. I installed Dask library, even though I'm not going to use it. But last time I think I showed it to you. So I kept it this way. And then these are the steps for the data insights. I'm importing some libraries: NumPy, Pandas, Matplotlib. Then I'm loading my accident data. So for some reason, my data was not picked correctly. So let's pick it again, because it was loading at that time. So since it did not load all of it, so let's load it again. So this one is loaded. And one thing I can just do that. And you can see option on import or select low memory is equals to false or something. It throw in some sort of an error over here, but I will just looking at the shape. Let's look at the shape. So this is the shape of the data. Looking at the data type and null value. I'm not going to talk about these again. I'm just quickly running my code so that I can get to the steps where I'm applying the missing handling value strategy. So I will look at it, and then I will do some write down some notes about it, and then I will look at the null value columns. This is important now. you can see that this particular column and this particular column has more than about 29% and 41% data missing. But rest of the other one, this one has only 2 values missing. This one has 1%. This one has 0.2%, 0.002, 0.02. These are very few values. That means this is 6.855%. This is 2%. And so many different things. You can see this is 6.85%. These are still so many values, 71,000 values. So I will be kind of like looking at it. Now you must be saying, I should drop all these columns which has less than 5%. Keep one thing in mind. Maybe those values are missing, not at the same level, which means when I plot the missing no plot, my missing no plot, it's going to look something like this. So it's going to look, let it load. It's going to look something like this. You can see all these values in this particular column in this. So these 2 columns, I will not touch them. This column, I will not touch it because it has more than 5% value. So I'm not going to touch it. This value, you can see, has missing values. You can see this particular level. There is no other values except these 2 columns were missing, which means the value missing in this column. If I remove the drop, or if I use the drop NF for this particular column based on this particular column, then it's going to remove all the rows over here. That means I will lose some data in this column as well. If I drop this one, it's going to drop all the row over here as well, even though it is not repeated. So this missing no is very good visualization technique, a good library for me. I use it very often because this gives me an orientation how much data I would be using. Yes, all of them are 0.1, 0.2, 1%, 2%, but adding all of them up sometimes can get more than 5%. So you can lose. So you have to double check what kind of a percentage of data you're going to lose. So this is the simple description. And last time I talked about how to use this description. Look at the minimum value, look at the percentile, 50%, 75% max. And this is going to tell you something, that this one value is repeated so many times. Then 2 value, which means 50%, almost about 40% of the data is 2 value, 40% of the data is 1 value, and there are a few values which are 32 as well. Over here, all the values until 75 percentile, it is 0, but then it is 2. And over here, the same thing is happening. So you have to take a look at that. So I'm not going to go in detail about that. Check for the duplicate values, unique values. I'm not going to in detail about it. Yes, if there are duplicate values, I'm going to drop the duplicate values, and then I'm going to check for unique values all over again. Now let's do the handling missing values, and we are doing the complete case analysis for now. First thing I'm going to do is I'm going to pull out the list of the columns that have less than 5% or greater than 0% missing values. So which means what I did is I basically wrote a list comprehension. What I'm doing over here is I need all the variables for variables in this particular column. So this particular column has several different variables. I want all the variables which satisfy this condition. So if their percentage missing value is less than 5% and greater than 0%, then I want the name of the columns. So that is what I'm doing. So I collected the list. What I'm going to do is I will create a new data set and I will play with that. So I have basically created a new data set, train columns. That means I'm looking at only those columns which fulfill this particular criteria. Then keep one thing in mind. There is one thing we call head. Head basically gives you a look of first 5 values. So when I do the head part over here, so let me do that. And when I do this, it's going to give me the first 5 values. But what if I want randomly pick 5 values from the whole data set? This way, what I can do is I can do sample over here. So if I do sample, it's going to pick 5 random values. And if I do it again, it's going to pick randomly other different 5s. You can see this is 62621. Maybe when I do it again, it did not pick up that one. So it is picking 5 randomly. So this is a good way to see what is happening, because looking at head and tail sometimes restrict you what is happening in the middle of the data, because you're just looking at the head and tail. So sampling it is a good way. It means you can change the number over here. You want to take a sample of 10 different rows. You can do that. So I'm going to stick with 5 for now. So this is what we did. Now I want to see how much of my data I'm going to lose if I drop all the values in this particular, the values which are missing only in these columns. Let's see. So what I'm doing is I'm figuring out the length of the data frame where I'm only picking up those columns which have less than 5% values missing. If I drop them, what would be the length of that data frame? And then I'm dividing it. So I'm calculating the percentage technically. And then I'm dividing it by the length of the original data frame. So this is going to give me 95. That means if I drop all the missing values using complete case analysis over here, I would be dropping just 5% of the data. That means I still have 95% of the data with me. And this is a good strategy, means you can always check that and you should be able to drop, because even if it is, so now you need to take a look at all these columns. Dropping this column would change my data, whether the value is missing completely at random or not. Based on that, you can get rid of some columns over here as well. But since right now I'm not talking about or not giving a lecture for domain expertise here, you need to play with that. Okay, so because I don't have an expertise in it, I have to do my separate research to get that information. Since I don't have it right now, I'm not going to discuss that. Okay, so then I'm going to take a look at the shape of the new data frame. So when I take a look at the shape of the new data frame, you can see I originally had 1,048,000. Now I have 1,007,000. That means I think we dropped roughly 41,000, I think 41,000 values, but we still have more than 1 million. Now let's look at the distribution of the new data set. So this is the distribution of the new data set, and I will compare it with the distribution of, I just used matplotlib over here, and this was my new data frame, which I created over here with the these columns dropped. And this new data frame, all these columns look like this. Now I'm going to plot every single column side by side on top of each other, not side by side, on top of each other, to check for the distribution, whether the distributions are overlapping or not. So what I'm going to do is I will do first for the second row number. So first column was, so now I need to do different strategies, whether it is numerical or whether it is categorical, I will do. So first I will pick the numerical values for say. So I just randomly pick second row number. I don't know why I did not pick this. Let's pick this first row number. Let's start with the first one. So when I go over here, I'm going to do this and I'm going to do this. Let's run it. So what did I do? Did I do something wrong? Yes. So I need to remove a space here and let's run it. So what I'm doing is I'm plotting the original data set with all the missing values still there in red color. And then I'm on top of it, I'm plotting the new data frame with the missing values. Do you see red and green apart? The original one is in red, the new one is in green. So which means, do you see red and green apart? They are 100% overlapped, which means I was able to get my distribution not changed here. That means on this particular column, this strategy, complete case analysis, did work right. So I will keep it this way. Then I can try the next column. So I can copy the next column over here. So what was my next column? My next column was this. Let's copy it and let's do it over here. So I'm going to do the second row number. When I'm going to run it, you can see the red and green are still overlapped, which means this column also did well when I removed the missing values from it. And I can keep on doing that for the rest of the columns. And if the distribution is changing, I will note down that column. That means this particular imputation technique over here did not work fine. Dropping the missing value did not work fine for that column. So I will go and I will keep it in the data as it is. Maybe. Since the values were not missing in a very large quantity, as you can see over here, the values were 0.002, only 29 values, only 269. But keep one thing in mind, when I dropped 5% of it, that means I did not just drop these two. I dropped 5% from every column technically. So which means even though it had only two missing values, but I dropped 5% from it in total in order to satisfy all of it. So you have to be very careful here. So okay, so we did that. And if you want, I can make a density plot, or in simple statistical term, we call it PDF, probability density function. So let's plot it and let's see, because yes, these are histograms. I can do it for different reasons. Over here, when you have continuous variable, let's say numbers or something, density plot would be a good idea, because when you have categorical data or something, you can do histograms. But if you have numerical data, you can do this. So, but you can still play with that. Okay. So over here, you can see it is running around because density plot is it takes time, because it is calculating some values. Since we have million of data points, it's going to take some time. Okay. Meanwhile, let's take a look. Joel Lewis, you were asking 95% of rows would be deleted. In what scenario? Okay, let me. Wait a minute. Let me share my screen. Okay, so I did talk about that. So let me show you for a few more columns here. Joel, the 95% is basically the data I still have, which means I'm dropping the rest of the 5%. So what I calculated is the percentage of the data I still have at hand. Okay, so I think I will do this. Okay, so let me share my screen maybe. Yes. Okay, so this is so what you can do is, since we have how many 9 columns here, you can do this particular code and keep on changing this for all 9 of them and see which ones are changing, if any one of them are changing or not. If they are not changing, amazing. If they are changing, then we have to do or check for the percentage change. How would we do that? So this is another data set. I'm getting this from one of my template, but I will share this notebook with you. So you would have all the data already, or all the code already, so you can play with that. But I'm copy pasting from it. I'm not going to write on my own. So this is another data set which I was working on. You can see different distributions. Or what I can do is I can just explain from this part as well. What I can do is I can create two different columns and I can look. So in this particular data set, what I did is basically it had different one column which has no enrollment or something, full-time courses and part-time courses. So these were the three categories when we were doing the enrolled university. So what was the category? One was enrolled university. I know that it is a different data set, so don't get confused. So what I'm doing is I'm basically concatenating. Concatenating means putting a table on top of the other. On top means adding the rows technically. So that is what concat function does. It puts a table and takes the table and put on top of the other one or below the other one, you can say. So since I'm kind of like adding the percentage of observations per category, this is the original one, and this is the when we did. So what you can do is you can find the percentage of a particular. So when we talk about categorical variables, you can, when you did this thing, you can check how many percentage difference has been created while fixing the missing values using complete case analysis. So you can look at the percentages. This is the percentage of this particular category in the data set originally. And this is the percentage we have right now after doing the complete case analysis, which means the percentage did not change as much. This is the same thing for the next category. This is the same thing for next. If it is not changing much, that is what you want. But if it is changing a lot, the numbers, this is 72, maybe this one is 68, that is a big change. So you need to be checking that. And how to check it? It's pretty, I'm just creating a temporary data frame and I'm just comparing it. I'm just calculating the percentages here. You can see that value counts for categorical variables. And we can do that. Maybe let me copy this and let me paste it here. And let's try it with one of the categorical variables of our own. So since this is trained and this is trained and this is new data frame, so that's fine. So one of the categorical variable, let's pick it up. Which categorical variable should we pick it up? Let's do light conditions maybe. So let's do light conditions. So let's look at light conditions and how many values have been changed here. So let's do light conditions. And what I'm going to do is temporary column, original, and CCA. You can see that when I applied the CCA, this was the percentage for this category inside light conditions column in our data set. You can see originally I had 72% values. I still have 72% values. Darkness, lights, lit, I originally had 19.8% values. I still have about 20% values, so pretty close. Originally, I had 5.7 or 5.8% values. I still have 5.8%. Over here, I had 0.8%, and now this is 0.66. So the change over here is, so you need to go and take a look at what are the numbers. What is the, what this number changes, that how many values have been moved. So this one is 0.4, this one is 0.4. In fact, this one did not change at all. That means majority of the values we changed from this particular category. This is a good information because what is happening over here is 0.8, it went to 0.66. That means majority of the values I dropped were maybe from this category. So which means I originally had a very less amount of data set or data values for this particular category in my data set. I already removed most of it. That is not a good thing, which means maybe I lost some good information. So you need to go and check how many values you are missing. And then you have to go and maybe do not remove those values. Get rid of this column from that particular category and see, can you fix it any other way or not? So this particular categorical column, I will be thinking about it because this number, I don't know what that number is. Let's calculate it. So if I do it quickly on the calculator, so 0.8 into 1 million. Okay, 0.008. So 8,000 values and 6,000. That means I dropped about 2,000 values here of this particular category. I originally had only 8,000 values, and I'm left with only 6,000 values, which means I dropped 2,000 of that particular categories, removed the rows, and that is not ideal because I originally had 8,000 and I dropped how many? 2,000 of them, which means I lost about 20% of that particular category, and that is a very big number. I cannot kind of like accept that. This is a very big percentage. So I would not be dropping this particular column. So I will keep this column out of my categories over here. So I will just get rid of this lightning conditions, and I will try it with all the other columns all over again. So this was just for one category. You can do it for another category. Maybe do we have another category? Yes, we have. Let's do maybe wet or damp, road surface condition. So let's see what happens for road surface condition. Let's go down and let's see. So what I'm going to do is I'm going to copy this code. Okay, Control C. So I'm going to copy it, and I'm going to do it for road condition. So let's road surface condition. Let's see. So road surface condition. Let's do it. You can see this particular category dry was 67.6%. It is 67.9, not much change. 28.8, 29, not much change. 0.22 or 2.2. This is 2.3. This is 0.7. This is 0.7. This is 0.13. This is 0.14. So this one does not change much. So I will stick with that. But the other one, I will not. So you have to do it with every column, and then you can determine whether this is a good strategy, this complete case analysis is a good strategy for that column or not. Since we have a lot of columns which are categorical, you would have to repeat it for every categorical over here to check it out. So that is a good way to do it. And means this is what we have for today in terms of let me share my screen. In terms of what we did over here. So technically what we covered today is how to deal with this particular case. In the next session, or most probably I'm recording these sessions, most probably maybe you will be able to see some videos this weekend, during this week, because I have time this week. So most probably I will record them. I will be covering the univariate techniques, step-by-step numerical columns and categorical, and then I will be covering the multivariate techniques, both of them. And I will talk about the mathematics behind them, why exactly they are taking so long, what are the advantages, what are the disadvantages, what are the assumptions, and when to apply it and when not to apply it. All those questions, just like we did with the complete case analysis, we are going to do with the rest of the other techniques. Okay. So I think I would have to finish up today's session at this point. The video will be uploaded. The notebooks, I will put them. Don't worry about it. If you have any questions, please ask.
Thanks very much, Salman. Great session. Does anyone have any questions now, or if you think of any, if you don't have any questions now, just DM Salman on Slack, and I'm sure he'll get back to you as soon as possible.
Yep. Okay, so okay, I think if no questions, then I will see all of you most probably next meeting on Saturday, and then on Sunday again. So yep. Thank you, everyone.
Thanks very much, everyone, for attending, and thanks, Salman. We'll see you soon.
Yep. See you. Bye-bye.